guys, welcome to ISYE 3770. This is going to be your first lesson on set operations. So what exactly is a set operation? We can define it as a way to compare multiple sets, such as set A, B, C, etc., in relationship with each other under certain circumstances. And so there are different set operations that we're going to go through. Our first one is called a union, kind of looks like the letter U, and we can say that a union is almost like an OR statement, as in it's going to include all of both events. We can remember that this symbol is a union because the word union begins with the letter U, and the symbol kind of looks like a letter U. And visually, if we're looking at two sets, let's say set A and set B, a union is going to include everything of both sets. So A or B and the intersection in between. Our next set operation is called an intersection, and we can think of this as an AND statement. And this is going to include only the outcomes contained by both events, such as the intersection of sets A and B. So if we're going to visualize this again, we'll have just the intersection of A and B, where the two overlap. Another is called a complement, and in this case we'll have the complement of A. We can denote this by writing an apostrophe after the set. And complement is a not statement. And this is a set of outcomes not in the event or not in the set, or in other words, like the opposite. And so if again we have A and B, if we want to write A not, then it's going to be everything that A is not. So in this case, it'll just be this section of B. Another set is called the null set. It can be written like this, or it can be written as a literal empty set. And the null set is actually contained in all sets. So let's look at an example of this. Let's say we have set A, and we'll do 1, 2, 3, 4, and 5. And let's also define a set B. We'll do 1, 3, 5, 7, and 9. Let's say we want to look for A union B. Well, as we defined earlier, since this is a union, it's going to contain everything in A and B and the intersection in between. So this is going to equal 1, 2, 3, 4, 5, 7, and 9. If we want to do A intersection B, this is going to include only the values in A and set B that are overlapping. So in this case, we'll have 1, 3, and 5. If we want to find the complement of A or A not, this will be everything that is not in the set A that is contained in the set B. In this case, it'll be the values 7 and 9. We can see this by understanding that the values 1 through 5, 1, 2, 3, 4, and 5 are contained in the set B. The values 1 is here, 3 is here, 5 is here. And the values that are not contained in A are just 7 and 9 that are contained in set B. Now let's say we want to find A naught with the union of B naught. Well, we already defined A naught as being the values 7 and 9. And if we want to find the intersection, or excuse me, the union with B naught, well, B naught are all the values that are not in B that are contained in A. And so in this case, it'll be the values 2 and 4, since these values are in A and they're not contained in B. So we can write 2, 4. And if we want to find the union of this set and this set, well, it's going to be, as we defined earlier, everything in A and B. So we can say that is the set 2, 4, 7, and 9. And since we have the null set, which we defined here, the null set is contained in all sets. So we can say the null set is contained in set A, the null set is in set B, and actually in all of our answers, they all contain the null set. Now, let's say we want to add a set. We'll call it set C. And set C, let's say it just has values 1, 2, and 3. Some cool properties about set C is that set C is actually a subset of set A. That means all the values contained in set C are also contained in set A, including the null set, which isn't explicitly stated here, but since the null set is contained in all sets, the null set is a subset of set C, which is a subset of set A. We can also write subsets as C is the subset of A. And that's just a quick overview on sets. I hope y'all were able to learn something new, and I hope this was a good review.